A black hole is not a hole, nor a vacuum cleaner searching for matter to consume. It is a massive concentration of matter packed into an extremely tiny space, an object formed when a star's core violently implodes. To understand this, look at a living star's mechanical balance. Gravity's inward crush is perfectly countered by nuclear fusion's outward push. When fuel runs out, fusion stops and outward pressure vanishes. Gravity instantly wins, crushing the star's mass to a point. A black hole represents the total mechanical failure of these balancing forces. It is the final state reached when gravity overcomes every physical mechanism holding matter together. Without any outward pressure to resist it, the core of the dead star falls inward on itself at a significant fraction of light speed. All of that stellar mass is compressed into a singularity, a region of infinite density, where the star's matter is squeezed into a volume of zero. This density dismantles the physical structure of atoms. The empty space is eliminated, and subatomic particles lose their individual identities. Inside the singularity, space-time curvature reaches infinity. At this scale, the standard equations of general relativity and particle physics no longer provide a functioning description of reality. This concentration of infinite mass bends the surrounding spacetime into a steep, bottomless pit. To climb out, an object must reach a specific speed threshold called escape velocity. As the funnel walls become steeper, the speed required to break free increases. The required speed scales with the curvature of space. The closer an object gets to the singularity, the more energy it must expend to move away from the center. Near the singularity, gravity transforms from a simple pull into a geometric trap that demands impossible speeds to overcome. The universe has an unbreakable speed limit. Nothing, including light, can travel faster than approximately 300,000 kilometers per second. Because the escape velocity increases as space bends, it eventually reaches the speed of light. This boundary is the event horizon, the point where the required speed to leave the black hole exceeds the fastest speed possible in our universe. Inside this boundary, all possible light paths are warped so severely that they point only towards the singularity. Because an object can only move along these paths and cannot exceed the speed of light to reverse its course, the center of the black hole is no longer just a location. It becomes a moment in the traveler's inevitable future. The event horizon is a mathematical partition. It creates a region of space that is physically disconnected from the rest of the observable universe. Crossing the horizon introduces a violent disparity in gravitational pull called tidal forces. Gravity becomes drastically stronger over a distance of just a few meters. The gravity on an object's leading edge is vastly higher than on its trailing edge. This force stretches the object vertically, while compressing it horizontally into a thin stream of matter, a process known as spaghettification. This mechanical stretching operates on a scale that exceeds any known chemical or molecular bond. The object is physically disassembled into a stream of subatomic particles. As the leading edge of the matter accelerates toward the center faster than the trailing edge, the object loses all structural coherence, becoming a part of the singularity's mass. Gravity does not just distort the three dimensions of space, it alters the flow of time. This effect, known as time dilation, causes clocks to tick more slowly as they move into regions of higher gravitational curvature. To an outside observer, the traveler appears to slow and stop just above the event horizon. Their image reddens and fades as light takes longer and longer to escape the gravity well, eventually appearing frozen in time. The traveler's own perspective is the opposite. They feel time passing normally even as they cross the boundary and experience the final, rapid collapse toward the singularity. The black hole is the universe's most extreme boundary. It is a region where the density of matter and the curvature of time converge to a point where neither can continue to exist in a measurable form.